Have you ever looked up at the night sky and wondered what those faint, cloudy patches of light really are? Maybe you've seen pictures of spectacular spiral shapes glowing in deep space and thought, what exactly am I looking at? Well, you're looking at galaxies. Massive ancient collections of stars, gas, dust, and mystery floating through the cosmic ocean. And here's the wild part, our own planet, our sun, everything we've ever known, exists inside just one of these cosmic giants. Today we're going to explore what galaxies really are, how they're built, and why they matter. We'll dive deep into their structure, discover the different types, understand how they're born and how they die, and explore some of the most fascinating galactic phenomena in the universe. By the end of this journey, you'll never look at the night sky the same way again. What exactly is a galaxy? Let's start simple. A galaxy is basically a huge collection of stars held together by gravity. But when we say huge, we mean really huge. We're talking about hundreds of billions of stars, sometimes even trillions, all bound together in a cosmic dance that's been going on for billions of years. Think of a galaxy like a cosmic city. Just like a city has millions of people, buildings, roads, and parks all organized in a certain way, a galaxy has stars, planets, gas clouds, and dark matter, all structured by the pull of gravity. And just like cities have different neighborhoods with different characteristics, galaxies have regions where stars are being born, areas where old stars are dying, and quiet suburbs where things are relatively calm. Our own galaxy, the Milky Way, contains somewhere between 100 to 400 billion stars. That's more stars than there are grains of sand on some beaches. And the Milky Way is just one galaxy among an estimated 2 trillion galaxies in the observable universe. Let that sink in for a moment. 2 trillion galaxies, each one potentially harboring billions or trillions of stars. The numbers are so vast they almost lose meaning. The building blocks of a galaxy. So what are galaxies made of? Let's break it down piece by piece. First, stars. These are the most obvious component. They're the glowing points of light we see when we look up at night. Stars come in all sizes and colors, from tiny red dwarfs that burn for trillions of years, to massive blue giants that live fast and die young in spectacular supernova explosions. In between, you have stars like our sun, medium-sized yellow stars that can shine steadily for about 10 billion years. Stars aren't distributed randomly throughout a galaxy. They're organized into different populations. Population I stars are younger, metal-rich stars found in the spiral arms and disk of galaxies. Population II stars are older, metal-poor stars found in the galactic halo and globular clusters. These different populations tell us about the galaxy's history and evolution. Second, gas and dust. Between the stars, there's a lot of empty space, but it's not totally empty. There are vast clouds of hydrogen, helium, and tiny particles of dust. These clouds are where new stars are born. When gravity pulls enough gas together, it heats up, ignites, and boom, you've got a brand new star. Some of these clouds, called nebulae, are absolutely stunning to look at. The Orion Nebula, for example, is a stellar nursery where thousands of stars are currently forming. The gas in galaxies exists in different states. There's cold molecular gas in dense clouds, warm atomic hydrogen spread throughout the disk, and hot ionized gas in the halo. Each state plays a different role in the galaxy's ecosystem. The interstellar medium, as astronomers call it, is constantly being enriched by dying stars and swept up into new generations of stars. Third, dark matter. This is the mysterious stuff we can't see but know is there because of its gravitational effects. Scientists estimate that dark matter makes up about 85% of all matter in the universe. It's like the invisible scaffolding that holds galaxies together. Without dark matter, galaxies would fly apart because there wouldn't be enough visible matter to generate the gravity needed to hold everything together. We know dark matter exists because of how galaxies rotate. The outer parts of galaxies spin faster than they should based on the visible matter alone. The only explanation is that there's a massive halo of invisible matter surrounding every galaxy, providing the extra gravitational pull needed to explain what we observe. And finally, there's usually a supermassive black hole lurking at the center of most galaxies. Don't worry, it's not going to suck everything in like a cosmic vacuum cleaner. But it does play a huge role in shaping how the galaxy evolves over time. These black holes can have masses millions or even billions of times greater than our Sun. The black hole at the center of the Milky Way, called Sagittarius A, has a mass of about 4 million suns. Types of galaxy. Not all galaxies look the same. In fact, astronomers have classified them into a few main types based on their shape. This classification system was developed by Edwin Hubble in the 1920s and is still used today. Spiral galaxies are probably what you picture when you think of a galaxy. They have beautiful swirling arms that spiral out from a bright central bulge. Our Milky Way is a spiral galaxy. These arms are packed with young hot stars and glowing gas clouds where new stars are constantly forming. The spiral shape comes from density waves, kind of like traffic jams in space, where stars and gas bunch up as they orbit the galactic center. There are two main types of spiral galaxies. Regular spirals have arms that connect directly to the central bulge. Barred spirals, like the Milky Way, have a bar-shaped structure of stars running through the center, with the spiral arms extending from the ends of the bar. About 2/3 of all spiral galaxies are barred spirals. Elliptical galaxies are more like cosmic footballs or eggs. They range from nearly spherical to stretched-out ovals. These galaxies are usually older and contain mostly red and yellow stars, with very little gas left to form new stars. They're like the retirement communities of the universe. Elliptical galaxies range in size from dwarf ellipticals with just a few million stars to giant ellipticals with trillions of stars. Giant elliptical galaxies are often found at the centers of galaxy clusters, where they've grown fat by cannibalizing smaller galaxies. These cosmic bullies are some of the most massive single objects in the universe. Irregular galaxies don't have a clear shape at all. They're lumpy, chaotic, and often the result of galactic collisions or gravitational disturbances. The large and small Magellanic Clouds, visible from the southern hemisphere, are examples of irregular galaxies orbiting our Milky Way. Despite their messy appearance, irregular galaxies can be sites of intense star formation. There are also lenticular galaxies, which are sort of in between spirals and ellipticals. They have a disc-like spirals but no spiral arms, and they've mostly stopped making new stars. They're like spirals that have run out of gas, literally. How do galaxies form? This is where things get really interesting. Galaxies didn't always exist. In the early universe, right after the Big Bang about 13.8 billion years ago, there were no galaxies at all. Just a hot, dense soup of particles expanding and cooling. As the universe cooled, gravity started pulling matter together. Small clumps formed first, then merged into bigger clumps. Dark matter played a huge role here, creating gravitational wells that attracted regular matter. Over hundreds of millions of years, these clumps grew into the first galaxies. These early galaxies were small and messy compared to the grand structures we see today. They were probably more like irregular galaxies, chaotic and actively forming stars. But over billions of years, they collided and merged with each other, growing larger and more complex. Galaxy formation is still happening today. We can watch galaxies interact and merge using powerful telescopes like the Hubble Space Telescope and the James Webb Space Telescope. The process of galaxy formation is intimately connected to the formation of large-scale structure in the universe. Galaxies don't exist in isolation. They're organized into groups, clusters, and superclusters, forming a cosmic web of matter separated by vast voids. This structure formed because dark matter clumped together first, creating the framework that regular matter followed. Our home galaxy, the Milky Way. Let's talk about home. The Milky Way is our cosmic address, and it's absolutely massive. It's about 100,000 light-years across. That means if you traveled at the speed of light, it would take you 100,000 years to cross from one side to the other. Our Sun is located about 26,000 light-years from the center, out in one of the spiral arms called the Orion Arm, or sometimes the Orion Spur. We're basically in the cosmic suburbs, and that's probably a good thing. The galactic center is a crowded, intense place with that supermassive black hole and lots of radiation. The Milky Way is constantly moving too. It's rotating, with our solar system cruising around the galactic center at about 515,000 miles per hour. Even at that incredible speed, it takes about 230 million years to complete one orbit. The last time we were in this position, dinosaurs were just starting to appear on Earth. Think about that. In the time it takes our solar system to make one lap around the galaxy, entire species rise and fall on Earth. The structure of the Milky Way is complex. There's the thin disk where most of the stars and gas reside, including our Sun. Above and below the disk is the thick disk containing older stars. Surrounding everything is the galactic halo, a roughly spherical region containing ancient stars, globular clusters, and most of the dark matter. And at the very center is the galactic bulge, a dense collection of old stars surrounding the central black hole. The Milky Way isn't alone either. It's part of a small cluster of galaxies called the Local Group, which contains about 80 galaxies. The largest members are the Milky Way, Andromeda, and the Triangulum galaxy. The rest are mostly dwarf galaxies, small satellites orbiting the larger galaxies like moons around a planet. Galactic collisions. Here's something that might blow your mind. Galaxies crash into each other. And it's not even that rare. In fact, galactic collisions are a normal part of cosmic evolution. When galaxies collide, it's not like a car crash where everything smashes together. Remember, galaxies are mostly empty space. The stars themselves rarely collide. Instead, the galaxies pass through each other, their gravity pulling and stretching both structures into new shapes. It's more like two swarms of bees passing through each other than two solid objects colliding. These collisions can trigger massive bursts of star formation as gas clouds slam together and compress. The pressure from the collision causes the gas to collapse and form stars at a rate much faster than normal. These collision-induced starbursts can be so intense that a galaxy forms more stars in a few million years than it would normally form in a billion years. Galactic collisions can also feed the supermassive black holes at the centers, creating brilliant quasars that can outshine entire galaxies. As the galaxies merge, gas and stars are funneled toward the centers, feeding the black holes and causing them to grow rapidly. The energy released during this feeding frenzy can be visible across the entire universe. Our own Milky Way is on a collision course with the Andromeda galaxy, our nearest large neighbor. Don't worry, this won't happen for about 4.5 billion years. When it does, our two galaxies will merge into a new, larger galaxy that astronomers have already nicknamed Milkomeda. The night sky will look completely different during this merger. Andromeda will grow larger and larger in the sky, eventually filling our view with a spectacular display of cosmic chaos. The collision will last for billions of years, with the two galaxies passing through each other multiple times before finally settling into a single large elliptical galaxy. Our solar system will probably survive intact, though we'll be flung into a different part of the merged galaxy. The Sun will have long since swelled into a red giant and engulfed the Earth by then, so unfortunately no humans will be around to witness this cosmic spectacle. Active galactic nuclei and quasars. Some galaxies have extremely bright centers that outshine all the stars in the galaxy combined. These are called active galactic nuclei, or AGN for short. The energy comes from matter falling into the supermassive black hole at the center of the galaxy. As matter spirals into the black hole, it forms an accretion disk, a swirling disk of superheated gas. The friction in this disk heats the gas to millions of degrees, causing it to emit incredible amounts of light and radiation. Some of this matter doesn't fall into the black hole, but is instead blasted out in powerful jets traveling at nearly the speed of light. Quasars are the most extreme examples of AGN. They're so bright they can be seen across most of the observable universe. The brightest quasars can be 1,000 times more luminous than the entire Milky Way galaxy. Most quasars existed when the universe was young, between 1 and 3 billion years after the Big Bang. This suggests that supermassive black holes grew rapidly in the early universe, feeding on abundant gas before galaxies settled into their current forms. Why galaxies matter? So why should you care about galaxies? Well, understanding galaxies helps us understand where we came from and where we're going. Galaxies are the factories where elements are forged. Inside stars, hydrogen and helium are fused into heavier elements like carbon, oxygen, and iron. When stars die, especially in supernova explosions, they scatter these elements into space. This enriched material eventually forms new stars, planets, and yes, even us. We are literally made of stardust from ancient stars in our galaxy. Every atom in your body, except for hydrogen, was created inside a star that died long before our solar system formed. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it came from stars. You are the universe experiencing itself, made from material that has been recycled through multiple generations of stars over billions of years. Studying galaxies also helps us understand the universe's history and fate. By looking at distant galaxies, we're looking back in time because their light has taken billions of years to reach us. We can watch how galaxies have changed and evolved, giving us clues about what the future holds. Will the universe expand forever, with galaxies drifting apart until the last stars burn out? Or will something else happen? Galaxies hold the answers. Galaxies also serve as laboratories for studying extreme physics. Where else can you find supermassive black holes, matter traveling at nearly the speed of light, and gravitational fields so strong they warp space and time? Galaxies let us test our theories of physics in ways we could never do in Earth-based laboratories. The future of galaxies. What does the future hold for galaxies? Well, that depends on the fate of the universe itself. Current observations suggest the universe will continue expanding forever. Dark energy, a mysterious force that's pushing the universe to expand faster and faster, seems to dominate the cosmos. If this continues, galaxies will drift farther and farther apart. Eventually, billions of years from now, galaxies outside our local group will recede beyond our observable horizon. Future civilizations, if they exist, will look out at a dark universe containing only the merged remnants of the local group. Star formation in galaxies will gradually decline as they run out of gas. The last stars will form perhaps 100 trillion years from now. After that, galaxies will slowly fade as stars burn out one by one. Red dwarfs, the smallest and longest-lived stars, will be the last to go, potentially shining for tens of trillions of years. Eventually, galaxies will contain only stellar remnants, white dwarfs, neutron stars, and black holes. Even these will eventually decay or evaporate over unimaginable timescales. The universe will enter a dark age, cold and empty, with only the faint glow of Hawking radiation from slowly evaporating black holes. But that's trillions of years away. For now, galaxies are vibrant, dynamic places full of life and activity. And we're lucky enough to live in an era where we can observe and study them. Conclusion. Galaxies are more than just pretty pictures in space. They're the fundamental structures of our universe, vast cosmic ecosystems where stars are born, live, and die. They're the reason we exist, the context for everything we know. The next time you look up at the night sky, remember that you're standing on a small planet, orbiting an average star, in the outer regions of a spiral galaxy containing hundreds of billions of other stars. And beyond our galaxy, there are trillions more, each one a cosmic giant with its own story to tell. That faint band of light stretching across a dark sky? That's your view of the Milky Way from the inside. You're not just looking at the universe. You're part of it. You're made of atoms forged in the cores of dying stars, scattered across space, and reassembled into a conscious being capable of looking back at the cosmos and understanding it. Pretty amazing, right? Otro. So what did you think? Did galaxies blow your mind as much as they blow mine? Drop a comment below and let me know which part fascinated you the most. Was it the galactic collisions? The supermassive black holes? Or maybe the fact that we're literally made of stardust? If you're new here, welcome to the channel. We're just getting started on this cosmic journey, exploring everything from galaxies and nebulae to black holes and the edge of the observable universe. Hit that subscribe button and join our growing community of space enthusiasts. We're building something special here, a place where curiosity meets wonder. And if you enjoyed this video, smash that like button. It really helps the algorithm show our content to more people who are curious about the cosmos. Think of it as giving the channel a little gravitational boost, helping us attract more viewers into our cosmic orbit. See what I did there? Also, if you have questions about galaxies or suggestions for future videos, leave them in the comments. I read every single one, and your questions often inspire the next video. Want to know more about black holes, nebulae, exoplanets? Let me know. Before you go, here's a fun thought to leave you with. Right now, at this very moment, you're traveling through space at over 500,000 miles per hour as part of the Milky Way's rotation. You're also moving at 67,000 miles per hour as Earth orbits the Sun, and spinning at about 1,000 miles per hour from Earth's rotation. So the next time someone tells you to slow down and relax, you can tell them that's physically impossible. You're literally zooming through the cosmos at breakneck speeds. Thanks for watching, space enthusiasts. Keep looking up, keep asking questions, and remember, we're all made of star stuff. Until next time, stay curious.